Good morning, everybody. This is going to be another test. This is part 2 of the A7 HVAC test, and so maybe we can learn something from this. And I tell you what, putting this together and creating these illustrations is extremely instructional even for anybody. You ought to try that. Question 1, a fully charged AC system with a compressor engaged shows low high side pressure and low side pressure. What's the most likely cause? A, slip-in compressor clutch. B, weak condenser fan. C, restricted orifice tube. Or D, an overcharged system. The answer is restricted orifice tube. Now, the deal with this is you're more likely to see this problem when you've got a faulty TXV, a thermal expansion valve, than you are a restricted orifice. If your orifice is restricted this bad, there's typically, the compressor is typically coming apart, or there's a lot of trash in the system anyway. So if you've got a really bad clogged orifice tube, you need to look at, see if you've got little Teflon strips from the internal part of the compressor in there, or if you've got other trash in there that got in there somehow, or something's coming apart. You need to go ahead and flush the system, replace any rubber hoses that may be coming apart on the inside, that kind of thing. There was a lady that had, that I mentioned one time before, I think. She had a 2012 Ford Escape, and that was a TXV system, and she could drive it for about 30 minutes and it would stop cooling. And so she had gone by the Ford place over in another city, and they said, no, you need to replace all of this stuff under the dash. It's going to be $1,500, blah, blah, blah. They wanted to put the whole plenum chamber under there. She called me, and I said, bring that thing over here, let me look at it. So I put the gauges on it, cranked it up. When it was cooling normally, everything was fine. And then, after about 30 minutes, it stopped working right, and the pressures were both low. And I said, well, you got a bad expansion valve. So I replaced the expansion valve. 16 bucks. It was at the college, I just had the students replace it, and our air conditioner worked perfectly after that. All you gotta do is watch those pressures. Whenever it stops cooling, you can figure out what's wrong with it instead of guessing. Okay, so there was another one though that was very strange. It was a Toyota Camry, an older one. It had the expansion valve under the dash, and it had low pressure on both sides, and it wouldn't cool. I mean, this was all the time. And so we put an expansion valve on that one, didn't fix it. And so I said, well, there's nothing else it can be, but it's something wrong with the evaporator. Although the evaporator seemed like it passed air pretty good when you blew shop air through it with everything, take it off there. But we put an evaporator on that one and fixed it. There was this one guy that had done air conditioner work for years. He said, when I ran out of all other ideas on one that had refrigerant issues, I always put an evaporator on it and fixed it. But anyway, that's what we found on that one. So this is usually, you're more likely to see this with an expansion valve problem than you are with a clogged orifice, because the expansion valve can fail in such a way to where it throttles the refrigerant all the time and doesn't work anymore. Especially if that little alcohol diaphragm leaks and quits working or whatever. Now this is a close-up design. You can look at that. Notice how you got high pressure gas coming out of here, condenses, gives off heat, the refrigerant that you picked up over here. Wait a minute, let me get my laser turned on. Discharge, this is where you're going to be measuring your high side pressure. And I've built this illustration just for this PowerPoint presentation, so y'all feel privileged, okay? You won't see this anywhere else online unless I posted it there, or maybe you see it on carparts.com or OBD Advisor, because I review for those two outfits. All right, liquid line, high pressure liquid. Here's your orifice tube. If the orifice is clogged, it can't get anything here. In normal circumstances, this low pressure liquid goes into the evaporator, turns into a gas. It boils at like 21 below zero or whatever, depending on, and so then it comes out of here as a low pressure gas, and any condensation of the refrigerant or whatever, there's liquid refrigerant and there's oil mixed with it in here. Some of that's picked up. There's a screen here, a little tiny hole in this tube. It picks up oil in there and it draws it out. Notice this cannot get any liquid refrigerant at all out of here. Period. And so the only thing it can do is draw gas through here, mix a little oil with it, pull it over here, and it's like oil, and it's like a chainsaw, you know, with the oil mixed with the gas, and it comes over here. This is typically where you're going to be taking your low side pressure. On some of the Jaguars, this port here is underneath the vehicle, close to the driver's side front tire. I don't know why they put it down there, but anyway, or why Jaguar did. The suction line is the big line. It's the one that's always cold. If you're charging one up, like on a tractor or a front end loader or something like that that's got an air conditioned cab, and you don't know how much refrigerant to put in it, just keep putting refrigerant in it until this suction line is cold all the way to the compressor. When the suction line is cold all the way to the compressor, and is nice like sweaty like a glass of tea, then you know you got enough refrigerant in it. If it'll start to get cold over here, and then the cold will work its way over here, but it needs to be still absorbing heat all the way to the compressor as a low pressure gas, and then the compressor will squeeze it into a high pressure gas, and the circle continues. And so I hope that I tried to make this just as clear as I possibly could, and I worked probably an hour and a half on this schematic trying to get it right. Question 2. A vehicle's AC system blows warm air. Manifold gauges show higher than normal side pressure and lower than normal high side pressure. See, this is the opposite of the previous thing. Most likely cause is restricted orifice tube, an overcharged system, a weak failing compressor, or a failed condenser fan. This is a weak and failing compressor. This is one I took a video of the gauges in the shop. This was a scroll compressor. Scroll compressors love to fail. They don't take a lot of energy to turn, not like a regular piston compressor. The way they're designed, you know, they work really well when they're working, but they like to fail. I mean, the seals on the end of the scrolls mess up, and it's, you know, it's just real easy. I had a picture of this particular compressor taken apart so you could see the inside of the compressor, but I didn't take the time to look that up because I got thousands and thousands of pictures in my library, and I don't even remember what I named that one. But anyway, this question 3. Frost is forming on the suction line near the evaporator. What is the most likely cause? Now, it's only near the evaporator. Inoperative expansion valve, restricted cabin air filter, slipping compressor clutch, or very low refrigerant charge. This was one that we found a bunch of, looked like catfish food or something on the you know, one of my students is holding that, restricted cabin air filter. Can't get enough air across there. Airflow is restricted if you got a failing blower motor, you know. There's not enough heat crossing the evaporator coils to boil the liquid refrigerant. The liquid carries over into the suction line and continues to absorb heat in the engine bay. I mean, a lot of heat, more than normal, causing the line temperature to drop below freezing and form ice. Now, sometimes when, you know, usually if you have frost forming on the on that suction line, usually that means a problem. Most of us won't go chasing that problem unless there's also some kind of another problem, like the evaporator's freezing up or something like that. Because it's one of those things where, you know, you can be a stickler and work on something that's not broke just because you don't like the frost on the suction line, but sometimes because of humidity and other factors, you're going to see frost on the suction line. So the frost alone is not a reason to go looking for a problem. Okay, if the air conditioner's cooling real good, frost on the suction line, you know, unless you're, you know, I mean, I guess you could probably use that for upsell, but, you know, and upsell is something I don't typically enjoy, and customers pick up on that whenever you try to upsell them, and then they go to another place and said you don't need that stuff. You know, that happens every day. This is one question. The blower motor doesn't work on high speed. What's the most likely cause? A, faulty blower motor switch. B, out of balance fan motor. C, failed blower resistor. Or D, stuck open blower motor relay. All right, so this was what this is on medium speed right here, see? All right, it's going through this last resistor. If it goes through all of them, it'll turn really slow, but this is a right under high. All right, it goes through this normally closed terminals, which is where the terminals at rest here, and you can see this motor turning down here, kind of slow. Now let's make a switch. We're going to switch it back and forth and let you see what's going on here. switch to high, you see it's supposed to energize the relay, pull these contacts over so that it gets power directly, through no resistor, past that. And that switch, that high switch, energizes that relay. This is on a GM. This is on like a Chevy pickup. This is not the way it works on every single vehicle. Some of them just bypass all 4 resistors and go directly to that. But usually, like on a lot of the vehicles, there's power to the fan motor all the time, and the ground is what goes through the resistors. So remember that too. But if this relay, if these contacts are stuck over here and they won't snap over to this side, even if all the fuses are good and everything else. Now if this fuse is blown, you'll have the same issue. But if that relay is stuck over here and it won't switch to that side, then you're not going to have any high blower speed. You'll have, the first 3, 1, 2, 3, those right there, off, basically sends a signal to the control head on this one. Low is going to run it through every one of these. This is a stepped resistor assembly, they call it. And GM on this particular one, this little thing has got the blower relay built into it, by the way. And one time on a Lincoln that had a electronic temperature control, they had the blower built into the assembly that regulated the fan speed. This guy said when he hit a bump, fan speed would kick on to high. And so I said, well, that's interesting. And so I got out there, and the control head, whenever it wanted high blow, would energize the high blow relay, which was where internals similar to this, but it was all part of that same block. And so kind of like you see right here, except it was electronic and had anyway, the long and short of it was, I drove it, but hit a bump, it switched to high blow. I brought it back into my service bay, used my long extension like a Q stick, and I just, while the thing was blowing on low or medium blow or whatever it was, I just reached over here and I bumped that blower resistor, because you could see it under the hood on that Lincoln, and it kicked into high blow. And I said, well, there's something wrong with that blower resistor. So I went ahead and got a $100 blower resistor and put it on there. Didn't change a doggone thing. Well, it turned out the control head was leaking 8 volts out to the coil on that blower relay. Wasn't supposed to do that. There was supposed to be no voltage at all. And so I said, well, this is a $400 control head. I've already spent $100 of this guy's money. I could tell him, well, I put the blower resistor on there, but that didn't fix it. Now you're going to need a $400. That just got crossways with me. It might not with everybody, but it did with me, because I hate that kind of thing. When like when I hear that something happened like that, or sometimes you can't help it, even if you try to do everything right. What am I supposed to think? I bumped the thing and it blows on high. So I took the gauge tester that had these little potentiometers on it, and I connected it to that circuit coming out of that control head, and I dialed, it's basically like I was shorting that 8 volts away, but I started with high resistance, and I kept working it down, and I figured out that, I can't remember how much resistance it was, but whenever I got it to the point to where the blower would work right, but it wouldn't kick on high when you bumped it, that was like 50 ohms of resistance between that circuit and ground, was basically bleeding that 8 volts to ground instead of letting it go to the relay. I took the top of the control head off, which you could do on that one, and soldered seemed like it was a 50 ohm or 150 ohm, I can't remember. Might have been 150 ohm, I don't remember. Whatever the resistance was that I measured from that my gauge tester had delivered that had fixed this problem. I put a resistor in there, fixed that thing permanently, never had any more trouble with it. But that was one that I basically engineered a fix, and it was nothing wrong with it. It wasn't going to crash the car if the thing didn't work right, Worst case scenario, I'd have to tell the guy that, well, I tried to fix this, but you're going to have a control head. But he never had any more problem with it. Question 5. A vehicle has poor AC cooling at idle but cools well at highway speeds. What is the most likely cause? A. Restricted evaporator core. B. Highly overcharged system. C. An inoperative condenser fan. Or D. A failing blower motor winding. An inoperative condenser fan will cause this. This is an actual picture. Excuse me. With bad fan, you got high pressure on this side, high pressure here. Same vehicle with a good fan after we fix that. Now the way that I troubleshoot that is with the thing running there in the service bay, I took a good strong shop fan blowing straight into the grill. And that's putting air across the condenser, just kind of like you were driving down the road. If I see the pressures come down to normal, and it stops squealing the belt and getting the head pressure too high or whatever, then I know that it's going to have a fan. Now, it can be the viscous fan on a belt-driven fan not working right, or it can be a problem with the electric fan. But if you got one that overheats in the drive-through, but it doesn't go down the road, then or basically the head pressure goes up, and if you do there's a pop-off valve on some of the air conditioner compressors. When head pressure goes too high, it'll go, "Duh!" and then you'll see some steam come out from under the hood, which is kind of spooky. But if you've got an intermittently operating cooling fan that's got an open commutator segment like I've shown you before, it'll do that too. It may not do it all the time, but if that cooling fan ever fails to come on, you're going to have high pressure. The AC is going to quit cooling, but you'll notice that at highway speeds it cools just fine. Question 6 on our 1234 YF system shows higher than expected high side pressure during charging. What's the most likely cause? All right, so that would be using an R134 service hose set. In other words, if you're going back and forth, even a clean hose has trapped refrigerant and pag oil inside the rubber. Now, this won't happen every time, but it can happen. And so you can cause a spike. You can read the words here. I'm not going to read those words to you, but you can pause the slide and read the words, and you can see what's going on there. So, question 7. A technician detects a sweet odor inside a Tesla cabin. In other words, in the passenger compartment. What's the most likely cause? A leaking heater core, B, a leaking refrigerant line, C, a leaking glycol chiller loop, or D, a failing cabin air filter. Of course, a lot of these Teslas have got 2 cabin air filters, one outside and one inside. Leaking glycol chiller loop. You notice the low voltage heater inside the HVAC case in the schematic. In a lot of Model Y configurations, this is a liquid to air heat exchanger. The internal seals fail or a hairline crack develops. Pressurized glycol, that's antifreeze, leaks into the air path. Blower picks up the fumes and pushes them through the dash vents, and you're smelling antifreeze. That the batteries are swimming in coolant, and the coolant is pumped through the motors and inverters and all that kind of stuff to cool them down. So there's a lot of coolant circulation going on these. You can kind of see there's that octo valve we were talking about in last week's test, sort of a diagram of that. And so I put this thing together too, which was I was trying to make sure it was right. You can see right here, this is your refrigerant, and this is coolant. The little lines are coolant. And so this, it's difficult to draw this exactly accurately all the time, but you can see what's going on there. So coolant's going to be your little lines, refrigerant's going to be your bigger lines. And, but this is not exactly right as far as, these words you're talking about, but you can see what I'm talking about. Coolant leak can happen here. There, you don't really see any coolant there, but one way or another. There it is. Zoomed in on that for you so you can have a look at it. Question 8. A Tesla heat pump system shows poor cabin heating in cold weather. What's the most likely cause? Now, the heat pump actually absorbs heat from the outside and brings it to the inside, just like the heat pump in your house. Same principle, but, uses different stuff. Is it a low AC refrigerant charge, weak interior blower motor, restricted front condenser, or inoperative inside sensor? Believe it or not, it's a low AC refrigerant charge is the answer to this. It's sensitive to refrigerant mass. Even a little undercharge reduces its ability to extract heat from outside air in the cold weather because it needs that refrigerant going through there, the right amount to be able to draw heat from out here and pump it into the cabin. And there's a zoom in on that one there. I created this for you guys too. This is sort of a overview. This is, not there. You can make this a whole lot more complicated than it was, but I tried to make it as simple. So the heat is actually absorbed here. That little thing is talking about the heat being absorbed here. But I put, that here's where basically it's absorbing the heat. And I should have drawn that line over here on both the other one and the front one. You see, after you create an illustration, I guess you can find stuff wrong with it later. And that's pretty much what I did here. Question 9. When using recovery equipment on an R1234 system, what's mandatory requirement regarding the procedure? A. Use a machine certified for safety. B. Heat the tank for faster recovery. C. Use R134 hose with brass adapters. Or D. Recover with the ignition switch on. Use a machine certified for safety. Well, what the deal is here is SAE standards J2843 require recovery machines use brushless motors and sealed switches to prevent internal sparks because R1234YF is kind of flammable. Of course, R134 is too, but R1234YF is more flammable. It's an A2L refrigerant. You can look that up whenever. Question 10. Tesla's AC system shows normal refrigerant pressures, but the cabin still does not cool. What's the most likely cause? A restricted subcooler condenser, an HVAC module software fault, a failed high-pressure cut switch, or a slipping AC compressor clutch? This is an HVAC module software fault, most likely. An AC system is fully software managed. If the pressures look normal, but the cabin still won't cool, that tells you something important. The refrigerant loop's working. The control logic is not. Well, that's the end of the test. We've been here 20 minutes. I hope you guys made it to the end of the test and didn't get bored and bail out early. And so, time to go to work. I'll see you guys next week. Let me know how you did on this and if it was beneficial.